Okay, we're going to use the data shown here to try and illustrate one more time how to do forecasting using exponential smoothing and how to calculate seasonal indices and to how to evaluate the accuracy of your forecast. So what we're going to do is start with exponential smoothing forecast first. Exponential smoothing forecast, and this data that I'm showing here might be different from what I sent through email because of the technical difficulties, we'll try to do this different times. So let's use the data that is showing right here on the screen. So let's create a column for forecast. And all forecasts have errors, and so let's create a column called error. And the error will be measured as the actual demand minus the forecast F. Exponential smoothing forecast always requires an alpha. So over here, I have the alpha, and let's say we start with experiment with a value of 0.3. As you may know, alpha cannot be more than 1, and it cannot be less than 0. So what we're going to do is prepare exponential smoothing forecast. And exponential smoothing forecast is a very simple way of remembering how to forecast using exponential smoothing. To say my forecast for period t plus 1, f t plus 1, okay, is equal to the forecast for the previous period ft plus a fraction. A fraction of the error. That fraction is determined by the alpha. So plus alpha, let's call it A, times the error of the, let's call it E for the previous period, ET. Okay, so your forecast, let me make this bigger. So your forecast for period T plus 1, okay, is equal to, let me change the font to make this one a subscript. So the forecast for period T plus 1 is equal to the forecast for period T, the previous period. Okay, I'm also making this one a subscript. Plus alpha times the error for period T. Okay. So my forecast for, again, any period. So if I want to forecast for March, for example, then T plus 1 is February. So the forecast for March, let me just call it MAR, forecast for March, M, equals forecast for February, FEB, plus alpha times the error E for February. So that, and then you repeat it. So the forecast, for March, MAR, equals forecast for February plus alpha times error for February. Similarly, if I want to forecast for October, the forecast for October is the forecast for September plus alpha times the error for September. So it's that simple. So every month you have to calculate the error, and then after that you use it to forecast for the next month. Okay? So in exponential smoothing, you always be given a beginning forecast. So let's assume that my beginning forecast for January is 105, for example. Okay? Then the error is the actual, for January is the actual minus the forecast. So that error equals this minus that. Okay? So that's my error, 15 for January. Now with the January forecast and the error for January, I can forecast for February. Okay, so the forecast for February is going to be equal to, using the formula that we have down here, is equal to, okay, so it's equal to the forecast for February plus alpha, which is this one here, 0.3, times the error for January. So the forecast for February is equal to the forecast for January plus alpha times the error for January. And that's my forecast. It says your forecast is 109.5. And I can copy this formula down for all subsequent periods because it's going to be the same thing. But to do that, I have to be mindful that my alpha 0.3 is not changing. So in my formula, I need to fix that. So if you're using Microsoft Office, I'll hit Microsoft operating system. I'll hit F4 on my keyboard, and that will keep it constant. So the alpha is not changing. And so with that, I can copy my formula down for, we'll stop at September now. Now you notice that the answer is the same because I don't have any error values. So I'll need to copy how I calculate the error also. That the error is always going to be the actual minus the forecast. So for the error for February, it's going to be this minus that. So I'm going to copy it down and notice how my formulas change. Okay. So you notice that sometimes the error is positive, sometimes the error is negative, sometimes positive, sometimes negative, and so on. So the error can be positive or negative. And basically, that's how I calculate. So if I'm at the end of September and I want to calculate for October, I just drag this down here. And it says your forecast for October will be 133.6 because it's going to be the forecast for September plus alpha times the error for September. And it's as simple as that. That's how exponential smoothing forecast works. Now, if I want to find out how accurate my forecast method is, then there are two things I can calculate. One of them is called the MAD, the mean absolute deviation. Okay, let me write the definition down here. So MAD is the mean absolute deviation, and it means that, mean absolute deviation. That means the average of the absolute errors. Okay, the average of the raw errors is called the bias. So we can calculate the bias by finding the average of these errors. So let's do that first. So my bias is going to be the average of these errors. So it's equal to average so my bias is 10.59. Okay, the bias is the tendency to over forecast or under forecast. So here the value is 10.59, which means that in general my actual demand was higher than on average than the forecast. So I have a positive bias. That's because I calculate the error this way. Now what we're going to do is take the absolute values of the errors. Let's call it ABS error. Okay, so we're going to take the absolute values of the errors, and that means that for each error you just equals ABS. Okay, this value, the absolute value of that error. So 15 is 15, and you just copy it down. Okay, so negative 1.23 becomes 1.23, and the MAD is the average of these errors. So the MAD at the end of September, I cannot calculate the MAD including October because I don't know what the demand for October is yet. Okay, so to calculate the MAD, I'm just going to do here MAD. MAD is going to be the average of these values. So it's equal to average E6 through E14. So that's 18.37. So that's my MAD. Now, is this a good MAD value or not? I don't know. I can experiment with different alpha values, and we're going to come to that in a minute. Okay. There's another measure of my forecasting system that I can calculate, which is called a tracking signal. Okay. Let me write it down here. Tracking signal TS is equal to what we call the random sum of forecast errors divided by the MAD. Okay, so the tracking signal is giving out to you so many MADs, 3 MAD, 4 MAD, and so on. So to calculate and let me write what RSF means. RSFE means equals running sum of forecast errors. What that means is that as I go from one period to another, I'm going to be adding up my forecast errors. Okay, so let's put a column here that called RSFE. Okay, so RSFE is we're going to be adding these errors as we go along. So we're going to say sum. This is equal to sum these errors, sum from January all the way to September, or however number of periods I have. So it's equal to sum, this. So if I'm in January, I'm only summing up for January. So I'll sum up for D6 to D6. And then if I come to February, it will be the sum of January's error and February's error. So I can calculate this form, copy this formula down. But to do that, I'm always summing up from January. So I'm going to fix this one here. D6, I'm going to hit F4, and you to put dollar signs in front of it. That means it's fixed. It doesn't change. You're always adding up from January. And then I'll copy it down now. So I'm always going to be adding up my errors from January. But because of the positives and negatives, sometimes some of the errors will be less than what they were before, and sometimes greater than what they were before. So this is my sum of forecast errors. I can also calculate the MAD for every period. Okay, the MAD is the average of the absolute errors. So in January, my absolute error is 15, so I have only one number, the average will be 15. When I come to February, I will add 15 and 20.5 and find the average. Okay, and when I come to March, I'll add 15, 20.5, and 34.35 and find the average. So that's how you calculate the MAD. So let's say the MAD equals the average, okay, of these absolute errors. So the average of these, and I'm always going to be, again, summing up from January, okay, and I'm going to go ahead and fix it up. I'm going to be averaging from January, so I'm going to go ahead and fix it up. So I can copy it down, okay. So you notice that, let me make sure that this is correct. So this is the average of this. This is the average. Okay, I didn't fix the E6, so I need to fix this number here. I thought I did, but hit F4. Okay, and now let me copy it down. Okay, good. So you notice that this number here is the same as here. That means this number was the average of all these numbers. And it's the same thing that I've done here. So 18.37 is the average of all these numbers. And if I'm at any month like April, my MAD is going to be the average of what it is for January, February, March, and April. And I can find that by hitting F2 on my keyboard. So if I hit F2, it says the average of this number. See, it's highlighted for you in blue. It's showing you the numbers that are going into the average. Okay, so that it means that this formula here for calculating MAD is correct. The same thing with the random sum of the forecast errors. For example, if I'm here, is the sum of all the errors from January through July. And if I hit F2 on my keyboard, it's going to highlight it for me. You see, it says sum of all the numbers highlighted in the blue. So that's one way of checking the accuracy of any formulas that you put in Excel. You can always hit F2 and it shows you how it is calculating it. Okay, so we have our MAD, we have our random sum of forecast errors, so we can calculate the tracking signal. Let's call it TS. And remember, TS is equal to RSFE divided by the MAD. Okay, so that's my tracking signal. So here, it means in any month, my tracking signal is equal to this divided by that. So that's very easy. So this is equal to this divided by that. Okay. Oops. And so I have 1, and I just copy it down. Okay. So my tracking signal is 1, 2, 3, then it goes back down to 2.51, 3.72. Typically, if you have a good forecasting method, or if your forecasting is working properly, your MAD should be between plus or minus 4. So the MAD can be positive. I mean, the tracking signal can be positive or negative. Your tracking signal has to be between, say, plus or minus 4. So it can be positive or negative. Okay, so this is how you, but if I'm only going to find out which methods to use, then I can compare them on the basis of the MAD. The lower the MAD, like we have here, the better the forecasting method. So for example, if I were to change alpha to say 0.8, okay, my forecast will change. Look at my MAD, it's now 22.03. So comparing alpha of 0.3 and alpha of 0.8, alpha of 0.3 is better because the MAD there was 18.37 and the MAD here is 22.03. If I were to change this one to say 0.05, okay, look at what happens. My MAD again is 23.12. So if I'm comparing, 23 alpha of 0.05 or alpha of 0.8, then it says alpha of 0.8 is better because it got a lower MAD. Okay, so you can also graph your forecast and see graphically how your forecast changes with every MAD values. Okay, so what I'm going to do is I'm going to insert, let me highlight this here. So we want to see how our forecast behaves, okay, with changing alpha values, and we're going to do it graphically. So I'm going to highlight this data, and I'm going to go over here, insert, a line graph, select this one here, and look at what happens. See, this is my graph, okay, of my forecasting. I can cover it up here. And this the red is forecast actual here. You have the periods over here, and these are the forecast values and the actual values. Now look, when alpha is 0.05, look at my forecast. It doesn't change too much from month to month. My demand is changing, but my forecast is not changing very much. So you see your forecast is not very responsive, okay? Now let me change this to 0.3 and look at what happens. Look at how my forecast moves out. It tries to be more responsive. It sees the demand going up, so it starts going up. Then it sees the demand coming down, it starts coming down. Then the demand starts going back up again, it's going up. And so it's trying to adjust to the demand that is occurring. Okay? And I can change this also to 0.8. And then look at what happens. It even changes more rapidly. Okay, so the demand is changing rapidly, the forecast is changing rapidly. So changing alpha allows you to see how your forecast changes with changing demand. When alpha is large, your forecast is very responsive. When alpha is low, 3.1, look at what happens. The forecast is very smooth. It's not very responsive, okay? So that's one thing to keep in mind. Now let's go back to our question. So I'm going to delete this graph. I don't need it anymore. I need the space over here. Now we're going to, so I'm going to just delete this graph here. Now we want to see which alpha value to use. A high alpha value or a low alpha value. Which one gives us the highest MAD? Or, the lowest MAD, the best MAD, okay? So what I'm going to do is I'm going to create what is called a data table. I'm just going to write here data table. Okay, and so for the data table, I'm going to experiment with different values of alpha. And I'm going to ask Excel to always calculate for me what the MAD is. Okay, so here in the data table with only one variable, you leave this space here blank. And I'm always going to put MAD in this column. So I'm going to start with one MAD value. You see, how do I calculate my MAD? This is my MAD. My MAD is average, this number here, which is the average of all these, okay? Again, look on here. This is the average of the absolute errors. So that's what I want Excel to calculate. Always calculate for me the average of the absolute errors, which is posted as E17. So I'm going to put in some alpha values, say 0.05, 0.1, and I'm going to increase them for some periods, okay? So let's go here. Okay, let's say I stop at 0.75. Okay, so I'm going to experiment with different values all the way, incrementing by 0.05 all the way to 0.75. So you've set out your table now, you highlight this table here. So you highlight these two columns. Okay, and then you go to, on Excel, you go to Data, What If Analysis, select Data Table, and what you want Excel is asking you for either changing the row input cell or the column input cell. And what I want you to be changing is the numbers in this column. So I'm going to use a column input cell. So I'm going to go here and say change this. Now what does it change? It's changing the alpha value, okay? So I'm going to go back up here and say the number that I want you to be changing is this one here, the alpha, which is this one here. Cell B2 is what I want you to change. So I want you to change cell B2 with these different values and always calculate for me the MAD. So I'll click on OK and look at what happens. It's calculated different MAD values for me now. Let's make this one a little bit cleaner by just making it 2 decimal places. Okay. So what it says is when alpha is equal to 0.05, your MAD is 23.12. Now let's look at the one when alpha is equal to 0.1 up here. Look at our MAD, 20.58. Look at it over here. When alpha is equal to 0.01, MAD is 20.58. So this is working. When alpha is equal to say 0.7, MAD is 20.96. Let's confirm that. Let's put 0.7 over here, and let's see if we get 20.56 or whatever over down here. 20.96. So when alpha is equal to 0.7, MAD is 20.96. Let's look at it. When alpha is equal to 0.7, MAD is equal to 20.96. So this formula is working. Excel has calculated for us for every value of alpha the corresponding value for MAD. Okay, now we want to find out what the best MAD is. The best MAD is the MAD that gives us the best alpha. We want to find out what the best alpha is. The best alpha is the one that gives us the lowest MAD. Okay, so let's look at it. When alpha is 0.5, MAD is 20.12. As we increase alpha, look at it. The MAD is decreasing. Okay, so around 0.25 is 18.32, but when we increase it to 0.3, MAD starts going back up again. It keeps on going back. So it means that the lowest MAD is somewhere here about 18.32, and it corresponds to an alpha of 0.25. So I can say that by experimenting with different values of alpha, I see that the best one to use for my method, given this data, is alpha of 0.25 because it gives me the lowest MAD. So I can highlight it here, and I see that it gives me the lowest MAD. Below 0.25, the MAD is higher. Above 0.25, the MAD is higher. So this gives me the lowest MAD. So my best method to use, if I'm using exponential smoothing, the best alpha to use would be 0.25. Okay, so that's how you can experiment with different values and arrive at your conclusion. So what I want to do, one more last thing that I want to demonstrate is the use of seasonal indices. The seasonal index just compares the demand with what the average is. So I have, let's say, the demand from January through September, okay? And I can find out what my average demand is, okay? So the average, if you want, I can write it here. The average, and this average is just going to be the average of all my demand. So my average demand is 132. I don't need to have so many decimal places. So let's say 132.8. Okay, so my average demand is 132.8. The seasonal index is how does this 120 compared to the 132.8? Is it higher or lower? So a seasonal index just tells you that on average, let's say your January demand is less than the average, but your September demand in general is higher than the average. So to calculate the index, let's call it SI, or seasonal index. Okay, we're just going to take each period's demand and divide it by the average. So this is equal to this divided by that. And the average is not going to change, so let's fix it. And this is 9.903. So I will copy it for all the periods. Okay, and I can highlight this and decrease the number of decimal places to, let's say, 2. Okay, so the September demand is 1.05 times the average demand. The May demand is 1.21. The March is that. But the January and February are less than the average. April is less than the average. And you can find out whether these numbers are correct because they should average 1. Okay, so I can find out what the average is. So the average index should always be 1. So this one equals, okay, average C is 1. Because some of them are higher, some of them are lower, but on average, they should be equal to the average, okay? So that's how you calculate average seasonal indices. Now, if I want to do a simple, we're going to call it a simple exponential smoothing forecast with seasonality. That means that you take the forecast that you have prepared previously and you multiply it by the seasonal index. Okay, so January's forecast instead of 1.05, the fact that January's demand is typically less than the average, it means my forecast should be less than 1.05. So I take this number, so this is equal to the forecast multiplied by the seasonal index. Okay, so the forecast for January should actually be, let's say, about 95 units instead of 105. And that's because in general, January's demand is 90% of the average. So then I can copy this now. Okay, and again, I can make it. Okay, so that's how I calculate the exponential smoothing forecast, simple exponential smoothing forecast with seasonal index or seasonal correction. There are more complicated way of calculating exponential smoothing forecast with seasonal indices, but this is a simple one that also works. Okay, so that's what you're supposed to do for the homework for those of you who haven't done it yet. Okay, so we started by first calculating the simple exponential smoothing forecast. Okay, and then we calculated the performance measures by calculating the MAD. Okay, we also calculated the bias, calculating the MAD, and then we calculated the tracking signal. Okay, so for example, when alpha is equal to 0.7, the bias is 5.16, the MAD is 20.96, and the tracking signal varies between 0.98 and 3. And then what we try to do is to find out what's the best alpha value to use. Should it be 0.7, 0.3, 0.1, and so on. So we use the data table to do that experiment, change the different values of alpha, and then calculate the MAD. And from there, we find out that the best alpha to use is 0.25 with a corresponding MAD of 18.32. That's the lowest MAD, and it corresponds to an alpha of 0.25. Okay, and then with that, after that, we also calculated seasonal indices, which is you compare the demand with the average demand, and then you can forecast, forecast with seasonality. Okay, and so you take the seasonal index and you multiply it by the forecast that you have prepared before. So that finishes our coverage of forecasting with exponential smoothing, calculating seasonal indices, evaluating which alpha to use for your exponential smoothing forecast.